Hello. The purpose of today's lesson is to look at oxidation numbers, or sometimes known as oxidation states, which is a topic that's new to you at A-level chemistry, not something you'd have seen at GCSE. It's a really important topic, though. It's very important you have a good understanding of it because your understanding will be built upon with the topics that you look at throughout A-level chemistry. So we're going to look at them today, how to work them out. So there are rules attached with working out oxidation numbers. The first is that any uncombined element has an oxidation state of 0. Now that is always the case. Anything that is uncombined will have an oxidation number of 0. So for example, if we had sodium, or indeed we can have a molecule as well, bromine, they have an oxidation state of 0. When hydrogen is combined, it has an oxidation state of +1. Certainly, initially, that's what we're going to use. There are some variations, as always, with any good rule, there are exceptions to that rule. But as far as we're concerned, to start off with, when hydrogen is combined with something, it has an oxidation state of +1. The same with oxygen. That has an oxidation state of -2. Now, with a simple ion, that's just the charge on the ion. So potassium, we know that forms a +1 charged ion because it's in group 1. So we would say that the oxidation state of that potassium ion is +1. Same with bromide, Br-. That has an oxidation state of -1 because the charge on the ion is -1. When fluorine is combined, that has an oxidation state of -1. That's because it is the most electronegative element, if you like, so it forms that -1 charged ion. Anything in group 1, so lithium, for example, that again forms a +1 ion, so that will have an oxidation state of +1. And for group 2 as well, that forms +2 ions, so their oxidation states will be +2. For example, barium forms a 2+ ion. Now, the best way to really understand many of the topics we see in A-level chemistry is to put that to practice. Now, I've repeated the rules up on the top right-hand side there. That's going to help us. So first of all, the oxidation number for magnesium. Magnesium here is uncombined. It's just as an element in its elemental form. So that is going to have an oxidation number of 0. Now we have a molecule. So we have hydrogen and we have oxygen combined. So we need to know the oxidation states of both. Now, fortunately, they are both within our rules, and we can see that combined hydrogen has an oxidation state of +1, and oxygen has an oxidation state of -2. Now, you might look at that and think, well, they're imbalanced. Those two don't balance. But then we look at the formula, and that explains why. Because we have two hydrogen atoms, each with an oxidation state of +1, balancing out that one atom of oxygen that we have within that water molecule. Sodium, we've got a sodium ion here. That is in the +1 oxidation state, and we know that because the charge is +1. And potassium fluoride, again, we've got two things that are known by our rules here. We've got potassium, which is in group 1, so that's going to be +1 oxidation state, and fluoride is always going to be -1 because it's combined. Now, oxidation states get a little bit more complicated when we are faced with an element that doesn't fit any of those rules. So what we first of all need to do, if we have a compound and we need to work out the oxidation numbers within that compound, first thing we need to do is check the oxidation number rules. We then need to look to see if the compound has a charge overall. And from those two things, we should be able to work out any unknown combined elements. So the first example we've got here is sulfur dioxide. So that contains one atom of sulfur and two atoms of oxygen. Now, first of all, sulfur isn't within our rules, and sulfur is one of the elements that can have many oxidation states. So we're not going to be able to start with that. However, oxygen is within our rules. We know that combined oxygen has an oxidation state of -2. The second thing to look at is whether or not the compound has a charge overall. Now this doesn't. This sulfur dioxide isn't charged. So that means we need to make sure that the oxidation states balance out. And it would be tempting to therefore write that sulfur has an oxidation state of +2, but it doesn't, because we have 2 oxygen atoms, meaning that overall we have 2 times -2 for our overall negative component for that particular molecule, which equals -4. Overall we have no charge, so that means the sulfur has to be +4. Let's look at our second example here, which is the sulfate ion. Again, contains sulfur and oxygen, and this really illustrates how sulfur can have different oxidation states, because we're going to end up with something different here. First of all, we check our rules, and we see that oxygen is within those rules with its -2 oxidation state. We look at the charge overall and see that overall that sulfate ion has a charge of -2. So what we need to do is look at what the overall negative component for that element will be. We have 4 oxygen atoms, each with a -2 oxidation state. So that means the overall negative component for that molecule is -8. Overall, the charge is -2. So to partially balance that negative charge, the sulfur is going to be +6. So +6 for the sulfur, and it's good practice actually when you're writing these out in various equations that you'll have, just to write them over the top. The +6 for the sulfur is partially balanced out by the -2 that's associated with the oxygen. We've got 4 oxygens, so overall we have that charge of 2-. Now to finish up, we've got some more complicated examples here, just to test everything that we've seen in this short lesson today. You might want to pause the video here at this point and work through these yourself. First of all, we've got chlorine. Now, whilst that's a molecule, it's still just an element. So it's in its elemental form, and that means it has an oxidation number of 0. Sodium chloride, we've got next. Now, sodium is in group 1. So looking at our rules, we can see that anything in group 1 is in the +1 oxidation state. So the sodium is going to be +1. Overall, there's no charge. Therefore, the chlorine must be -1. Next, we've got an ammonium ion. So we've got a compound and it has a charge of + overall. Now looking at our rules, we can see that combined hydrogen has an oxidation state of +1. Overall, we've got a charge also of +1. We've got 4 atoms of hydrogen. Therefore, to again partially balance out that charge, the nitrogen is going to be in the -3 oxidation state. Nitrogen is another one of those elements that has many different oxidation states. And then finally, with the compound we've got here, we've got sodium, we've got chlorine, and we've got oxygen. Looking at our rules, we can see that sodium is going to have an oxidation state of +1. The oxygen is going to have a state of -2, but we've got 3 of those oxygens. So 3 times -2 is -6. Overall, that molecule has no charge. So we now need to look to see how we will balance out these elements in terms of their oxidation states. The oxygen in total, the total negative component, I should say, for that part is -6. The sodium is +1. So to balance that out to give no overall charge, chlorine is going to be in the +5 oxidation state. This is a topic that's well worth practicing, using those rules, practicing, checking your answers, and good luck.